The last two methods we're going to see can also be viewed as sort of special cases of the factor and cancel method. But again, the important thing is to remember that evaluating the function at, or trying to evaluate the function at the value for which we're computing the limit can tell us what to do and which of these methods to choose. So let's see, what's the rationalizing method? Once again, we're going to be dealing with a 0 over 0 form, but this time the numerator or the denominator, or both, include some roots, some square roots. Okay? And so because of the roots, we're unable to factor properly. Well, what we can do is we can modify the formula by rationalizing it. If you don't remember what rationalizing is all about, well, we'll review that in class, but you may want to start reviewing it on your own. Now, after you have rationalized, we can use both the factor and cancel method and or the expansion method, once again, to end up with something which can reveal the common factor and then cancel it and therefore arrive at the limit. Finally, the last situation that can happen is when you have a form of the type infinity minus infinity. Now, if you remember, infinity usually comes from fractions with a 0 in the denominator. So if we have an infinity minus infinity situation, probably this comes from a difference of two fractions. So the method that we're going to look at is look at what we are starting from and ensure that we have two fractions. Otherwise, the method obviously will not work. Let's say if you have a couple of logarithms, you can't do the method. But if we do have two fractions to begin with, what we can do is we can combine them into one fraction only by using common denominators. Then guess what? After you have combined it into fractions, we can use one of the previous methods. We can use factor and cancel if we can, or maybe rationalizing, or any of the other methods we've seen so far, to again look for something in common to cancel, and once again hope that we're going to get the limit. Now keep in mind, these are all methods that we can try to find, that we can try to use in order to find the limit, but none of these methods gives us any guarantee that the limit will be found. In fact, we don't even know if the limit exists, so there may be some situation where the limit does not exist, and therefore these methods simply will reveal that the method does not exist. Well, that's also a good thing. So try them out and try them in combination, try them on each own, on each one of them on its own. You want to try also using a method that doesn't quite apply in a certain situation, just to see what happens. But again, remember that if you're doing that, you're doing it to experiment, not because you think it's the right method. So see you in class for a whole bunch of exercises and examples.